This video is a bit of a departure for me. If you've seen my other programming related videos, I've been working on digital implementations of board war games. When I start a new project, I usually just copy previous project code and start from there, but that means I have to pare away all of the game specific code from the prior project, which can be a pain in the butt. Last weekend, I was thinking about creating a template wargame project with all of the basic architecture from my prior work, but which can serve as a relatively clean slate for a new project. As I've noted in earlier videos, I used the Qt application framework for my project. And I was out walking my dog and contemplating the project template. And I started thinking about the fact that I've never seen anyone make any videos about using Qt for 2D wargame type projects. I was feeling loquacious that day, so I got home, I launched OBS, and just started creating the video you're about to see. It's not a formal tutorial. It's basically just me coding a project in real time and talking through what I'm doing. It's just stream of consciousness programming. Although at this point I do have a working familiarity with Qt, which facilitated things. But I didn't reuse any code from my prior projects. And in fact, I didn't even review prior projects to see how I addressed various issues. So this is just warts and all programming relying on my residual knowledge. So there are in this video, there's some coding dead ends and backtracking. There's times where I'm just consulting the Qt documentation. There's times where I'm just pondering things, figuring out approaches, solutions, squashing bugs in real time, especially during the map zoom implementation. I'm not a monster, so I did accelerate the video when I was just typing or consulting the documentation or just pondering. There were also a few interruptions to attend to real life matters, but basically it's just me coding in real time. Just want to make clear though, I didn't implement any game rules logic or create a playable game. I'm primarily just demonstrating how to create and display the map and counters in a 2D type war game. So the purpose of the video is to sensitize prospective wargame coders to the potential of the Qt framework. I suppose my deeper purpose is to foster discussion of wargame programming more generally. So I apologize in advance for the occasionally choppy audio. I had a bit of a cold and I tried to edit out sniffles, coughs, and the many ums that seem to plague my public speaking. There's also some occasional creaking sounds from my headset cable rubbing against the side of the table. Sorry about that, but let's begin. The only groundwork I've done so far is to create this folder, this test folder. The executable will be built here along with some ancillary files, but also there's this images folder. And in the images folder is a representative selection of playing pieces, as well as the BAOR map. Just to take a quick look at that. Normally, this map is oriented 90 degrees counterclockwise, but that's kind of an awkward layout for purposes of this demonstration. So I just created a temporary copy of the map that's rotated 90 degrees counterclockwise. It's not essential, but just to make things a little bit more presentable. And to state the obvious, you could do this with any game and have to be BAOR or the Central Front series. For this project and for all of my wargaming projects so far, I've used the Qt graphics view framework. In Qt, the QWidget class is the base class of all user interface elements. Our application is going to use a subclass of QWidget called QMainWindow. And QMainWindow, here's just the conceptual overview. It's the base class for your typical desktop type applications. So you have the central widget, you have the surrounding periphery of dockable widgets. Surrounding that is a periphery of toolbars, and again, you can put toolbars, you can put dock widgets at the, up here on the side, and the bottom, the side, like same thing with toolbars. You can put toolbars on the top, on the right, on the left, on the bottom. And main window also has built-in menu bar and status bar. Now you don't need that for a wargaming application. You could just start from a plain old QWidget and do everything yourself, or you could customize these elements yourself, but it's just easier for this project to use Q main window. In any event, our central widget here is going to be Q graphics view. So in the graphics view framework, there's three basic elements. You have the graphics scene, which is a canvas, so to speak, on which all your drawing is done. You have Q graphics items, which are individual graphical items that are rendered by the scene, and in this case, things like your unit counters, your markers, other things. You can also draw on the graphics scene itself, as you'll see. So it's Q graphics scene, Q graphics items, and then Q graphics view visualizes the scene, and you can use the built-in functionality of the graphics view to scroll, to zoom. You can use it to skew. Again, it's only for 2D type graphics. I mean, you could probably do something that approximates a 3D presentation, but at some point it's just not worth the effort. You might as well use a purpose-built system like Godot or Unity or whatever, or for that matter, Qt's OpenGL capability. Okay, so let's go to the editor. This is Qt Creator. Create a project. It's going to be a Qt widgets application. Call it game test. So we're going to, like I said, the main application window is going to be derived from Q main window. As you'll see, I'm just going to put these into subfolders. We'll use Microsoft Visual Compiler. No version control for this project, don't need it. So you can see Qt automatically generates your main function. First thing we want to do here is, I'm not sure if it recognizes C++23 as an explicit keyword here. Let's just copy this folder path. So this will tell the build system to create the executable file in this folder. Otherwise, it would create it in a subfolder in my source code directory. Okay, so just quickly show you. This is the form designer. It's a drag and drop type of interface. You can put different kinds of controls on it. Combo box, push buttons, line edits, all sorts of things. There's this whole menu of stuff that you could put on here. Right, and if you want to just get a preview, right, so obviously this is not a reasonable layout for an application, but just wanted to quickly show that. So you can see it's automatically set up a central widget. Right, it's already set this thing up for us. But you'll see in a minute that we're going to make a modification to that. So the first thing we're going to do is to we'll just call it map view. This is going to be our central widget. Not sure we'll be using signals and slots in this application, but we'll just enable that. Whoops. Okay, good. It's in the right folder. We need this for the form designer. So we don't want to use a vanilla widget for a central widget. So what we're going to do is promote this to now we'll create the scene class. We'll call it map scene. Just want to go back to the main function for a sec. This is all auto-generated for us. You can see that it creates a queue application object which handles a lot of the underlying plumbing. It creates an instance of main window for us. It calls show, which means I think widgets by default are invisible, so you need to call show in order for it to be seen. And then the main function starts, it calls exec on the queue application object. That starts the application's event queue or message queue running, and that's basically how GUI systems work. They're event driven, so you get messages from the operating system, from other parts of your application. But we don't need to mess with any of this stuff now. Just wanted to just quickly talk about that. For starters, let's start working on showing the map itself. Rather than having to escape these, we'll just use the other slash. Oops. Unfortunately, you'll have to put up with my horrific typing. Anytime I load something, I always like to do, even if it's a very controlled situation like this, this is Qt's debug output class, so I like to use that rather than cout. So if the file, if the pixmap doesn't load this file successfully, it'll basically be set to null. So this will tell us if it failed to load. I always like to go to Qt's documentation to remind myself of the function parameters. This is the documentation for the QGraphics scene class. We're going to implement this method here. We're going to override it. Basically, QGraphics scene a QGraphics scene renders itself in basically three phases. It first draws the background of the scene. We're going to use this to draw the map image. Then after that's called, it then calls the paint method on all graphics items that have been added to the scene. So they then draw themselves onto the scene. And then there's a companion function called draw foreground, which is called after rendering the QGraphics items, and that allows you to draw things on top of the QGraphics items if you want. There's a lot of flexibility in how you go about doing it, but I like to draw the map in the draw background method. So we'll now implement that. We're just going to suppress that compiler warning because we're not going to use rect. Oh, one thing I should do. The scene rect works hand in hand with the scrolling functionality and the zoom functionality in QGraphics View. You'll see that in our map view class, we will set the scene rect to be the same extent as the scene rect's rectangle, and that allows the map view object to do bounding checks to make sure that it doesn't like zoom or scroll or be dragged outside of the scene, or at least you can set it to enforce that. So that's a nice feature to have. If I'm not making sense, you'll see what I mean a little later. Now, so I think it's source. Always need reminders. That's the target rect. So now when draw background is called, it's just going to draw the entire map image aligned exactly with the scene rect, which is what we want, because up here we aligned the two. So in the main window constructor, we'll first create a scene object. Now the way the form designer works, it works with something called the meta object compiler with C. A lot of this is pre-generated for you. We'll go back to the form designer for a second. We'll go back to the central widget, and we're going to give it, instead of calling it central widget, we'll call it map view. Just make sure to save this file. Should recognize it. There, okay, map view. I think you have to do this manually. I don't think you get this for free when you set the scene. All right, let's see if it works. And there you go. I'm using the mouse wheel to scroll up and down. I'm using the arrow keys to do this. You can see by default the map view or the Q graphics view has scroll bars if the current view is outside of if the scene rect is larger than the viewport on the map scene, which it currently is. So that's how quick it is to get a wargame map showing. Now, I don't like scroll bars, so I'll show you what we're going to do here. So it should be implicit here, but if you just want to disable horizontal scroll bars, you can just call, you just call this without calling its vertical counterpart. But here we're going to do both. But now what? Obviously, we need to be able to move back and forth. So again, just going to get the override these three functions. You have to include this in order to be able to understand what the event does. We only want to do this in the event of a left button press. So what this does is allow you to left click and drag the mouse around. And actually, we don't need the mouse move yet. Also, extremely important, and you will drive yourself crazy if you don't do this. In most cases, you need to call the base class version of the handler either before or after you've done what you've done in your override version, because otherwise you're going to be bypassing behavior that you don't want to bypass. So, of course, my typing is utterly substandard. Pass the event to it. Again, I cannot stress how important it is to do this and how much time I've spent tracking down bugs that were simply a result of the fact of me not calling the base class handlers. Again, not always. You'll see if we do scroll, if we do zoom capability, you'll see we don't always want to call the base class version, but typically you do. All right, let's see if this works. There you go. That is how easy it is to drag stuff around. Okay, let's show some pieces here. So let's go back to our folder. So here we've obviously got unit counters. If you're familiar with the Central Front series, instead of step reduction, units collect so-called friction points. You can have up to 4 friction points before they're destroyed. So these markers are used to indicate friction. Obviously, in the game itself, you don't have these markers. They're just black markers that you put on top of the unit. But you'll see one of the nice things about a computer implementation is that you can do away with informational markers if you want by just integrating the information onto the counter itself. And that's what we're going to do with these markers. And in addition here, this is a non-unit type marker. So okay, so let's do this a little bit systematically. The first thing I'm going to do here is I like to, when I create is to create some type defs that are used throughout the UI layer in the game. Incidentally, that's something I should have explained at the beginning. The reason I created subfolders called UI is because I try to maintain separation between the UI layer and the rules engine layer and other components of the application. So if this were to be a full-fledged application, I would also create another subfolder called rules engine or simulation. I think I've also used or I know that I've used other subfolders for my command related classes, command design pattern. For my event classes, I have a subfolder for them. And I think I also have like a general folder for various things. But we won't be doing it in this project, but that's why I created a subfolder for this. But in any event, in my UI layer, okay, so we're here. You'll see in a minute why this is going to matter. Okay, now we're going to start creating the playing pieces. Called the unit item because remember, QGraphics items are the little pieces or the little graphical thingamabobs that you put on the scene. Now, QGraphics item is an abstract class, so there are several methods that you have to override. The first one, you see this is an abstract class. Now for this application, I know that markers are 65 by 65, or I should say unit. This better be 65 by 65 too. 65 by 65 pixels. So for this project, we'll set the oh, I gotta take 1 second. Sorry, I had some real life business to attend to there. It's a good thing I did take a break because this is not how I want to do this. We're going to do it a different way. So we know that unit counters and all the markers in the game are 65 pixels by 65. So incidentally, QRectF is just a rectangle class. The F is for floating point precision. There's also a integer version of it, but we need a QRectF. So the QRectF is going to be, so we're going to make it 32. Interesting. Do I need this? Is that what it's telling me? There we go. Now, why are we doing this? A graphics item has its own local coordinate system, and the bounding rectangle is the coordinates of the bounding rect are relative to the item's internal local coordinate system. By specifying this is the left coordinate of the rect, this is the top coordinate, this is the width, and this is the height. So this is basically the x and y coordinates of the upper left of the bounding rect, which means that the center of the bounding rect, in other words, coordinate 0, 0, is, the way we're doing it, is the center of the unit. It's going to be the center of the unit's graphic. If we wanted to have the unit have its coordinate system start at the upper left of the unit counter, for example, then this would be 0, 0, and still 65, 65. But the way we're doing it is we're creating a rectangle with its upper left coordinate at coordinates, x is minus 32.5, y is minus 32.5. Its lower right coordinate will be positive 32.5, comma 32.5. So I like to do that with my unit counters and markers in the game. By way of comparison, the scene rect, actually, its upper left coordinate is 0, 0. So in other words, the center of the scene rectangle is not 0, 0. It is, whatever half of the width and half of the height of the map image is. But in any event, so we're going to set the unit's local coordinate system so that the center of the unit marker is the origin of its coordinate system. Another thing to bear in mind is that we're setting the bounding rect at 65 by 65 to match the pixel count in the image. Depending on how you want to do things, you might want to set the bounding rect a little bit larger than the image and just center the image inside a slightly larger bounding rect. That would allow you to do things like draw a border around the unit, if like when you want to highlight it. There's different ways to approach it. For this project, we're just going to keep it very simple. So in any event, the bounding rect function that we have to implement will just return the static member function. Okay. Another abstract function that we have to implement is the type function. This just allows you to return a numerical value to identify. It's like a runtime type identification system that's built into Qt, or at least to the Graphics View framework. And here, we're going to harken back to this, right? Right. That's probably because right you are. this is why I could never be a professional programmer. And so the third function that we have to override is the paint function. Just so I don't have to remember all the parameters. See, it's an abstract function too. I know we're going to need this later. Just personal practice is to include standard C++ standard library functions before anything else other than the unit's own class definition. I know we're going to need this, so before we can really implement this, we have to do something else here. Qt has its own built-in string type. We'll just use that. This is the unit's name. That's the name of the image. Actually, that's not how we're going to do that. We're going to use pissmap. That does not sound right. Okay. So just want to do some basic validation. Remember, this is a path relative to the executable, and since the executable is going to be built here, and the relative path would be here. So let's take one of these French units. Well, what am I doing? And as we did before, just to make sure. Now, just a word here. You probably would not normally do this where you're passing image names to individual unit pieces. You might, but in a real game, you're probably loading all this information from a scenario file, and you might create like a master, like a vector with all of the game pieces or game images in them, and then just pass like an ID number or a handle to the unit so that it knows where to access its image. But just for the sake of ease, we're going to do it this way. And now we just do the same thing. What the heck did I call it? Image back, yeah. Obviously, I'm hallucinating here. Now, it just so happens, if I didn't mention it before, these are all taken from the Vassal module for the Central Front series, which is a nice module that someone put a lot of work into. You can see the naming convention here. Like the front of the counter is this, and then every back image has this, dash back, hyphen back in the name. So we can capitalize on that here. Again, depending on your game and how you do your image pieces, this isn't necessarily going to work, but so we can just use the same thing, but we have to add one more element here. And what we'll do here is Oh, forgot something very important. Once again, my typing skills are subpar. So, based on whether or not that show back member is set, we'll draw either the front image or the back image. The bounding rec is the same either way, at least in this implementation, in this project. Also, we'll get rid of this annoying, we don't need to use, this Q unused is just a Qt specific macro. So hopefully that's clear. Now, one other important thing we need to do, uint is a Qt type def for unsigned integer. As I mentioned, in the central front system, unit attrition, fatigue, supply state, etc. is modeled through the use of so-called friction points, and we'll integrate the marker right onto the unit. But we'll leave this for a moment. And you wouldn't normally do this, but for sake of this demonstration, we'll just create some units in the scene constructor. So now let's create that French unit. 1 RG1, okay. I think that's a Roman numeral 1. That's the unit name. This is the unit image, right? So when you're adding a graphics item to a scene, it's called the scene's add item method. Pass the pointer. Another thing that probably warrants comment, Qt has its own memory management model using parent-child relationships. Normally you create an object on the heap, you're normally giving it a parent object, and the parent object, when the parent object is destroyed in its destructor, it will delete all of its child items. And that's one way of managing raw pointers. The Qt graphics view framework uses raw pointers for things so that, you know, when you add an item to the scene, you have to pass a raw pointer to it. In my own code, in like my simulation layer, I'm pretty assiduous about using smart pointers. If you really wanted to figure out a way to use smart pointers with this system, I don't know if Qt has built-in smart pointers. They have something called a Q scoped pointer, which is probably like a unique pointer, but I do not believe that it works with the graphics view system. I could very well be wrong on that, but I've been using raw pointers. If you really wanted to use smart pointers, create, you know, unit items with smart pointers, and then use the .get method of a shared pointer, for example, to pass a raw pointer to the scene, you could, but now you have two parallel memory management systems going on. So I don't know if that's a great idea. So, you know, I just take chances with these raw pointers, but if someone wants to chime in and tell me that I'm an idiot, feel free. Before we add it though, let's give it a position on the scene. This one will just, setting up. What am I forgetting here? Yeah, set pause. We're going to set this one right at the center of the scene. that should do it. I believe graphics items are visible by default, so let's see what we get. Aha. Okay, let's figure this out. Yeah. Again, this is why I don't think I could ever hold a job in the industry. And this is why. Get more evidence of why I'm just not cut out for this. I'm a hobbyist at best. There we go. Okay, so here you have it. Now you see that it's not movable right now. So what you need to do in unit item is set flag. Sorry. So items are not movable by default. But now it is. I don't like the fact that we're getting this hand system there. I'm trying to remember how I got rid of that in my own projects. But, oh right. Do this quickly, show you. QList is just Q's version of a STD list. Oh, maybe we ought to tell the function where it is. Now it's important that when you pass it this point that it's in scene coordinates. You'll see how that so this function returns a list of all of the graphics items whose bounding rects intersect with this point. Do this a little bit more orderly. No, I'm not. This probably, it's important to remember that QGraphics scene and QGraphics view, their coordinate systems are different, and you have to map between them. So this takes oh, wait a second. Okay. Interesting. Okay, sorry, I just wanted to check the documentation for a moment. I want to make you sit through that. So that's fine. Map to scene. It's to ensure appropriate. Needless to say, you can only do this if you know that the scene associated to this view is a map scene. So, if the left button is pressed and there's no item under the cursor, meaning a unit item or something like that, only then will you be able to drag the map, and only then will you get the scroll hand drag. So just to show you what that's going to do. Right, so that's normal, but now we can drag the unit and there's no dragging. Okay, and there's no ugly scroll hand drag. Good, so that worked. Oh, I forgot what I was going to do. Oh, right, okay. Now, friction markers. We'll use the good old fixed. There are 4 types of friction point markers, so we're going to create an array of 4 images for those friction point markers, and we're going to make it static because we don't need each unit item does not need to have its own copy of these images. So I usually like to mark static functions with an S. And incidentally, we have to use pointers. We can't use pix maps. I keep calling them pis maps. We can't use pix maps because of something in the Qt framework that does not allow you, when the standard, when your static objects are initialized at runtime, the right portions of the Qt GUI framework haven't been initialized yet, so you would get a runtime error telling you that you can't create pix maps until you have a window, a functioning window. So for that reason, we're using pointers. But we'll initialize the array. And then we'll have this function. Might even want to do this. Make it a private function. Let's get the right name of the file. Okay, lather, rinse, and repeat. Okay, then in map scenes constructor, we'll call that static function. Oh, yeah. That would help. Let's just create a second unit. Some of you may cringe seeing me reuse a pointer to a heap allocated object, but this one. What's the name of it? 1421. Good old first armored. And we'll just offset it by 200. But this one, yeah, maybe that would help if we actually added the member. Okay. Since that's the maximum that you can have. And we'll call update, because if this happens at runtime, you want to make sure that the map image is, that the unit is, that it's updated and repaints itself. So here, if any friction points are accumulated, you want to draw the marker. Since these are pointers, we'll dereference it. Which is kind of superfluous because it's the same rect as the bounding rect, because everything is 65 by 65. So let's see if this works. Go back to map scene. Really? Did I really not implement that? Oh, didn't save the file. Let's give it one friction point. Okay, let's see if that works. Well, I'm guessing it happened here. Let's do a quick debug experiment. This is how you put output to the window, to the debug, to the application console window. Let's clear all that junk. Aha! That is because I'm a complete idiot. A complete idiot. Because there's nothing there. That's an uninitialized pointer. Hold on, gotta take care of some business. Sorry, real life keeps intruding. First of all, this is not a QGraphics item, this is a Pix map. Hopefully we won't need these debug messages anymore. So let's see if this works. Fingers crossed. And there you go. The unit has 2 friction points. Pretty this up. Okay, let's implement some zoom capability in the mouse view. Okay, so obviously I'm not... Interesting. That's because it's called wheel event, right? Okay. So this is the event handler when when the operating system passes a mouse wheel event. So depending on whether or not it's an up or down scroll, we want to either zoom in or zoom out. So I think we need to include the wheel event file, the wheel event header rather. Yep, that's it. Angle delta returns a Q point or Q point F, because mouse wheels, I mean, obviously they can scroll up or down, but you may have a tiltable mouse wheel that would also be a wheel event, and so that could be left or right. So that's why the X value from the Q point that's returned, that's for left or right tilts, but the Y value is for up or down. So can't remember which is which. Like I said, this can be a little tricky. So what we'll do is we'll keep track of the current scale. Whoops, there should probably be 1. So that 1 would basically mean no zooming in or zooming out. Or I should say it's not currently zoomed in or zoomed out. Let's say on the assumption that an angle delta y of greater than 0 is a zoom in, let's multiply it by 25% each time. Now here's the key. We don't want to allow too much zooming. Let's say we want a maximum zoom factor 4.0. Now, it's tricky because every time you call scale and pass a number to it, normally you would just pass two values. That's horizontal scaling and vertical scaling. And if they're different values like this, the image is basically going to be stretched. In this example, it would be stretched vertically. Typically, you would want to pass the same values, but this is matrix related stuff. This is the M11 value of the transform matrix, of the current transform matrix. So that's the current scaling. And like I said, we're always going to use symmetrical values here, so we can just call the M11 value. The other one might be of interest is the M22 value, but we'll just stick with that. This is what we would normally do, but because we want to make sure that we don't zoom in or zoom out too far, we'll either take the current value scaled up by 25%, or let's just say a maximum value of that. Okay, and we'll want the same value. In fact, why don't we be a little more rational here? The current value okay, so that's the new scale factor. We'll just pass that in twice. Again, this is why I can't hold a job in the industry, or I should say, I would never be able to, since I've never tried. And for the other zoom, we're just basically going to do everything in reverse. And why don't we say that this is actually zoomed out. Zoom out by a factor of 3. And I would also, I think we should probably, you don't want to zoom in if the cursor is over a unit or a marker, because you might want to reserve wheel. You might want the unit to be able to handle wheel events without also causing a map zoom. So why don't we try this test again? That strange sound in the background is my dog drinking water. Sorry, I paused recording to wait for my dog to finish making a very loud drinking sound, and then I realized I never had lunch and I was starting to fade. So I'm back. Of course, now my dog is gnawing on something in the background. So hopefully that won't be too loud. It occurred to me that, let me just show you how the zooming works before we put this capping on it. Okay, let's see if this works. There we go. That's zooming in, zooming up. That shouldn't have happened. And that shouldn't have happened. Heap corruption. Aha. Okay. Yes. Now I realize why I did that. Right. I think the problem is that we're actually ending up multiplying or dividing twice here. So let's take this out. Right. Having thought about this for a second, we need two tests here. Let's move this here. Let's figure out what this tells us what the current scaling is. Right. Because scale multiplies the current scale factor by this number, so we were actually multiplying it twice, which is not good. Okay, let's see if this works. Okay, that's zooming in. Okay, zooming out. Right, now see, if we don't put a cap on how far you can zoom out, you get the situation where you get all this, you're actually zooming out past this. This is the scene rect right here. The scene rect is coextensive with the map image rect. So if you just allow unbounded zooming, you get this. And also you don't want to allow zooming in too far because it just is a pixelated mess. Well, this is not good. Application wrote to memory after end of heap buffer. Well, that is not good. All right, we'll figure that out in a moment. So these values Okay, so that's as far as it'll allow me to zoom in, and this is as far as it'll allow me to zoom out. Obviously, those are not necessarily the correct values, but okay, I figured out what that heap allocation or access issue was, or at least I appear to have, because unit item, this creates images on the heap, and for some reason they were being written to after the close signal was received by the application. So what I did was just create this counterpart function. It's a static function also that just deletes all of the images that we created on the heap, and I added a destructor to map scene, which just calls that static function, and that appears to work. So that is my working hypothesis on all that. Okay, let's just go back to the map view. This was working. Okay, let's just make sure that it. Right, so I'm moving the mouse wheel now, and it doesn't zoom in, and that allows you to implement. If you want the unit items to handle mouse wheel input, you can do that without also creating a zoom. But okay, one thing, again, to state the obvious, these items can be placed anywhere. They're not constrained to like a center point in a hexagon. That is something, there are different ways you can approach it. What I've done in my other applications that have hex grids is in the rules layer, the rules engine layer or the simulation layer, there's a hexagon grid that's created, a logical grid, and each hexagon has a coordinate, XY coordinates. And in the UI layer in map scene, there are separate hexagon item classes, which are derived from QGraphics item. And so each hexagon in the rules engine layer will have its counterpart in the UI layer. So whatever the hex number is, 1729 in the rules engine layer will have a counterpart hex item here. And one way you could handle enforcing where units get placed is anytime you release a unit, in or near a hex, the map scene, or maybe you could do it in the unit class itself, the unit item class, will find the nearest hexagon and make sure that it adheres to the precise center of the location. Oh, not again. Sorry. 1 minute. Okay, I'm back. In any event, that gets into somewhat more complicated stuff that's, I would think, is beyond the scope of this video. But something that is important to point out is that, see, there's a problem. Why is this happening? This involves something called z-values. So in a 2D coordinate system or 2D graphical system, you have your x and y coordinates, and incidentally, the y-axis is inverted. So x values increase as you go from left to right, but y values increase as you go from top to bottom, which is different than the normal Cartesian plane system that you probably see in trigonometry class. But there's a third coordinate called the z-value, and a graphics item with a higher z-value is going to be drawn after an item with a lower z-value, which means it's effectively going to be drawn on top of it. So this British regiment has a higher z-value than this. And in fact, it's really not even a question of z-value at this stage, because when you add items to a scene, they are drawn in the order in which they are added, even if they have the same z-value. So as it turns out, these two items have a z-value of 0 by default, but this one is drawn on top of this one because it was added to the scene second. So how do we deal with this, at least in this elementary application? I can show you a quick and dirty way of dealing with it. This is not really how you would do it in a real project. In a real project, you would probably want to implement some stacking functionality. I'll just show you quickly how you can address this situation. And for starters, we're going to have to implement some mouse handlers. These are all the public functions for the QGraphics item class. It looks daunting, but you know, once you gain a little familiarity, it's not too bad. Let's start with the mouse press. I don't think we need mouse move, but mouse press and mouse release we'll need. That's the one we don't need, for now at least. Okay. So this variable will tell us whether the item has been grabbed. And I should add that Qt has a separate system in the graphics view framework. It is a separate way of keeping track of whether an item has been grabbed by the mouse. It comes with its own complications, and in practice I've avoided using it because it just doesn't mesh well with the kinds of things that I want to do. But I just wanted to put that out there because you could potentially use that instead of, or adapt that to your purposes rather than what I'm doing. Okay, mouse press event. We want to only do this if it's a left mouse press. Did we include the Okay, now here's where we're going to set the z value something other than 0, because by default it's 0. We can just set it to 1.0 for now. Oops. And you know, we may not even need this grab feature right now. Sometimes I try and prematurely optimize things or think ahead too far, but actually I think the set z value probably calls update. What I was going to say is the update function, sometimes when you set change attributes on a graphics item, it doesn't necessarily do anything to alert the scene that the graphics item needs to be redrawn. So you could call the update function, which will add the item with a list of things that the graphics scene needs to update or to redraw. So net this would cause a call to the paint function at some point. But let's try and I think that setting z value probably automatically calls update under the hood. So let's see what effect this all had. Okay, so remember this one was being drawn underneath this one. Let's see if, yeah, see, now we fixed it. Now this, well, right. How many times did I emphasize this earlier on in the video? I'm so glad you guys got to see this. If nothing else, hopefully this will I mean, that's what happens when you don't call the base class handlers. Okay, let's see if that fixes this. Okay, that works. And nothing disappears. But you see, once I release it, it still reverts to being on top, whereas this one will revert back to its original z value. But at least while you're dragging it, it has a higher z value, and so will be drawn on top of this. Again, in a real application, you know, if you want these things to stack together and you're not happy with the default ordering of things, I mean, you'd have to adjust the z value. So you know, I could show that in a different video. I've tried several different approaches to it, but in any event, just to call your attention to that. Okay, I think we'll do one more thing and then call it a day for this video. Remember, there is this, game marker. So we haven't done anything for that yet. So we're going to create a new class, also derived from QGraphicsItem. Call it marker item. I'm just going to use a very pared back approach here. In fact, we should probably, why don't we do it this way? Instead of calling it marker item, bridge item. Yes. Okay. Again, in a real application, you probably are going to have a centralized management system for image management, but just for this application, we'll do it simply. It is a PNG file, right? Yes, okay. And since I know we're going to need this, nope. Now, again, because it's a QGraphicsItem derived object, you have to implement those three functions: bounding rect, type, and paint. So just like we did for the item class, I think we made it. I just made it const, but depending on your application needs, you may not want to make this const, or you may want to leave this const and possibly have this not necessarily return the baseline rect. You may want to expand or contract a particular unit item's bounding rect depending on the circumstances. But again, this is a very simple implementation here, so we're just doing this in a straightforward way. It isn't necessarily suited to your needs. And again, if you recall, well, we called it marker, but let's call this bridge. We got to include that file. That's right. And finally, we need to do paint. Now we'll just draw the image. Let's see, the target rect, sorry. And the source rect would be, now, because the marker is intended to point to a hex side, we're going to have to actually, let's make this a double. I was going to get a little too cute. This is going to keep track of the direction in which the marker is pointing. So we're going to need to override, since we'll use the mouse wheel to rotate the counter. Nope, we didn't use the mouse wheel for that. Wheel event, there it is. My typing is substandard. What am I forgetting here? Yes, that's because the graphics scene wheel event is different than the wheel event used in the widget classes. So it's just called delta. It also occurs to me, how do you deal with left and right motion? All right. Now here we'll use one of the built-in functions. We'll use the built-in different ways we could do this. This is in degrees, I believe. Let's just see. Actually, I use the built-in help here. Yeah, okay, it's an integer value in degrees, or at least a value in degrees. So 1/6 of a full rotation is 60 degrees. So we didn't even necessarily need this, but and there's one other thing we have to do. I got to think about this one for a sec. And again, I think that setting the rotation automatically calls update, so we don't need to do it manually. But let's see if this works. Oh. it's definitely not going to work if we don't create a marker, a bridge item. So let's go back to the scene. Yeah, that'll do it. Okay, let's see if this works. There you go. Well, you didn't set it to movable. Let's see if it rotates. Well, now this is an example. Sometimes with wheel events, you don't want to pass the event on down the chain, but so it's movable, but it's not registering the mouse input, the wheel input. And this is why I, as a matter of habit, always include QDebug, because my capacity for messing things up is boundless. Let's just make sure that this is being called. Okay, applying mouse input. Let's see if it. Nope. I think you may have to enable a flag. Okay, I think I know what the issue is here. Now this sometimes causes issues, which is why I didn't. Well, that still works. Okay, there we go. The problem is it's also of course we didn't get the angles right. We wanted to orient towards the hex side there. Or try bridge item. See, what happened with that error was that because I didn't call the base class handler for graphics view wheel event, it wasn't propagating wheel event messages to any of the items on the scene. So now it is propagating it, but it seems to be causing some issues with the way it zooms. But right, so now it's right, because so it's zooming and so what if we don't do that? There we go. See, that's why I was saying sometimes the wheel events are an example of where you sometimes don't necessarily want to call the base class handler. So there you go. Now, with all that said, in a digital application where the system is controlling all of the placement and movement of these, I mean, you're not moving counters around. You're making various inputs to the application that would cause these items to be moved around in accordance with the enforced rules of the game. But so I guess what I'm saying is, if the game rules allow you to just to decide where the marker is pointed to when you place it, that's one thing, but you might not even normally want to have this kind of rotation ability, but obviously that's very game and application specific. But I just wanted to show you that it could be done relatively quickly, notwithstanding my various oversights. To wrap things up, I want to stress that there is a lot more to making a game than what I just showed. Just even in terms of UI behavior. I mean, I didn't show things like the menu, toolbars, status bars, dockable widgets. Maybe I'll do that in a future video, but that's really just the tip of the iceberg, because there's the whole rules engine layer that has to be done, and the interactions between the rule engine layer and the UI layer. In any event, I hope I made the point that, at least in my opinion, Qt is, if not great, then perfectly adequate for 2D style war games. Although there isn't really any 3D in the graphics view framework, you can do all sorts of 2D animations if you so desire. I'm actually finishing up another actual wargame project, and I should be posting a video of that in a few days. And in there are a few basic animations. I mean, nothing fancy, but at least it's a little bit more dynamic than what I just showed here. Qt also has other helpful features. It has a built-in networking library if you want to do multiplayer games. It also has a built-in scripting capability. It uses JavaScript. I think it can work with Python and possibly other scripting languages, but if you want to add scripting elements to your game, you certainly can. You can open a console and write scripts to change game behavior. I'm sure you've all seen that kind of thing. And for that matter, there's PyQt, which is a Python language wrapper around the Qt API, or the Qt framework. So basically, if you want to write applications in Python, in pure Python, I think you can. I don't even think you have to write C++ if you use PyQt. And there's also, I think, for example, Visual Studio has a PyQt plugin, so you could use Visual Studio if you don't like Qt Creator. There's also something called Qt Quick, which is another Qt technology, as the name suggests. It's an alternative to QWidgets based applications. It has hardware accelerated rendering, and it uses a declarative programming language called QML, which is I think a superset of JavaScript, and effectively allows you to embed JavaScript into the application that way. Supposedly Qt Quick and QML allow very fluid, glass smooth UI animations. I've never used it. I don't think it's really necessary for these types of minimal graphics war games, but it could be worth exploring. Also want to point out there's a book on game programming with Qt I have. Among other things, it also covers Qt Quick and QML, but I think the majority of it is focused on widgets applications, but that's a good place to start if you want to read more about it. As far as Qt itself, there are different licensing arrangements for Qt. The community version is free. You can't use it for commercial projects. I mean, you'll have to read the license and decide for yourself, but I think you're basically limited to open source projects with the community edition. But hey, it's free, and it has an awful lot of stuff in it. It is an immense framework at this point with lots of different aspects. I have not even mentioned most of it. So anyway, I hope this video was helpful and inspires you to pursue your own projects. I'm happy to answer questions within my abilities, which are quite limited. Constructive criticism is always welcome, and thanks for watching.